Hello students, today we will study the next topic, that is of chapter 5 standard 8 data handling. So this topic is chance and probability, right? So where we can use this chance and probability. So let us see some of the example that currently this is that is in rainy season, right? So what will happen in rainy season, that it is not happen always that every day that is a rain. So if there is something like 4 to 5 days, if there is a no rain, then what will happen? It is not happen that on the sixth day also there is no rain. It may be possible that on the sixth day there is a rain. So generally what will happen when you take the raincoat every day with you? You keep the raincoat every day with you and there is no rain on continue 4 to 5 days. Then what will you do? You take the raincoat to the home and go to school without the raincoat. And what will happen? On that day only the rain will come. So that is not predictable that it may be rain or not. Right? In the same way, second example we will take, like there is a test. Suppose there is a maths test of first 5 chapter and you very well prepared the fourth chapter, 1, 2, 3 and 4. Fourth chapter you prepared very well. But on that day only it is possible that on the test, in the test, most of the questions were asked from the fifth chapter. So what will happen? Whatever you prepare will not, you can get the proper marks in the test. Still, you prepare 4 chapter very well, but still you cannot get the good marks in the test. So it will happen many times. The third is train. Suppose you travel by train every day, and the train will come at exact time, right? So what you have to do, you have to reach the station at the time. But sometimes it will happen that you reach the station at the same time, but train is late. So these all are the examples in which we cannot predict the output, we cannot predict the result, that it may be rain or not. The test, which from which chapter the questions may be asked, and at which time the train will come. It may be either late or maybe early. It is not possible. It is not predictable. So these all are the examples in which we cannot predict the results. So some of the experiments are there in which we can get the proper output, that is getting a result, proper output we get. We can say that yes, this will happen or this will not happen. Surely we can say that. But in these 3 examples we cannot surely tell that the things will happen or not. So getting the results. So some of the examples, that is to toss a coin. Suppose you have a coin and you toss it, then what will be the output? It either head or the tail, because there is only 2 outputs. So it gives either head or the tail. So here we get the exact result. And the second example is to throw a die. Suppose you have a die and you know on the die there is a 6 faces and on each faces there is a number or dots. 1 dot, 2, 3, 4, 5 and 6. So when you throw a die, you surely get that the outputs may be from 1 to 6. Either it may be 1 or 2 or 3 or 5 or 6. Right? So these 2 are the examples in which we get some of the particular result. It is not like the examples we have taken here. Right? So that kind of experiment, like to toss a coin or to throw a die, this type of experiment is what the called is random experiment, right? So here we have to study some of the terminology that is related to the random experiment or that is related to probability, right? So first one is that random experiment that we have seen, that when you toss a coin or throw a die, that means that kind of experiment in which some particular result we can get. That kind of experiment is called the random experiment. Now outcomes. Second terminology is the outcomes. right? Outcomes means whatever the result we get, that is called the outcomes. Possible results that can be get, that is called the outcomes. And there is one more term is there, that equally likely outcomes. Now equally likely outcomes means what? Whatever the result we get, suppose it is possible that we can get head or tails, like there is an experiment to toss a coin. So two outputs are possible, head and tail. So both the outputs, so both the possibilities that we get, both the outputs is equal, then it is called equally likely outcomes. Then there is one more term, that is event. Event is also like the like term as outcomes, but it is slightly different. Event means what? Event means the particular result that we want. That is called the event. Output means, outcomes means, if we do one random experiment, there may be 5 results. It is possible that we get the 5 types of result, 6 type of result, 7 types of result. That all are called the outcomes. And event means that we want, which output we want, that is called the event, right? So we can define the probability. We can define the probability as required outcomes upon number of equally likely outcomes. Required outcomes, that which result we required, that we have to put here, and how many times that result occurs, that we have to put in the numerator. In the denominator we have to put the total outcomes which are equally likely outcomes. So this probability is only here we have to study about, in which the results, whatever the outcomes we get, whatever the outcomes is there, are all equally likely. Okay, let us understand all these things by taking two examples. The first example is to toss a coin. So to toss a coin is an random experiment. What are the possible outcomes are there? Either head or tail. That is the two possible outcomes. Neither there is not any other outcome is possible. So we can say that the number of events is also 2. One event is what? We get the head. Second event is what? We get the tail. The two events are only possible. So see, outcomes, number of outcomes is 2, head, tail, and number of events is also 2. But it is not possible in every case, right? So when we want to count the probability of getting head, this H means head. Now this is what? Head, that is the event. Probability of event. Probability of which event? Probability of getting head. And what we can write down it? See, head comes how many times? One time. So which is the required outcome? Head. In the denominator we have to put number of equally likely outcomes. So number of outcomes here are 2. So 1 upon 2 is the probability of getting head. In the same way, this is the second event to getting the tail. So probability of getting tail is also equal to how many times the tail out repeats here, how many times the tail here? One time. So 1 upon 2. 2 is because number of equally likely outcomes, and that is outcomes are 2. Understand? Okay. Now let us understand one more example, to throwing a die. So to throwing a die is what? It is a random experiment. What are the possible outcomes? Either we get 1 or 2 or 3 or 5 or 6. 1, 2, 3, 4 or 5 or 6. So the total events here is how many? 1, 2, 3, 4, 5 and 6. Total events are 6. Right? So number of equally likely outcomes are 1, 2, 3, 4, 5, 6. Okay, let us take an example. If we consider an event to getting number 1 on the die. So to getting number 1, that is probability of getting 1 is equals to C. How many times 1 occurs here? Only one time. So that in the numerator we have to put 1. In the denominator, how many outcomes are there? 6 outcomes are there. One thing keep in mind, we do not have to put the events in the denominator. We have to put the equally likely outcomes that we get. So here we get probability is equals to 1 upon 6. In the same way, probability of getting number 2 is also equal to 1 upon 6 because 2 occurs one time. Probability of getting 3 is also 1 upon 6. Probability of getting 1 upon 4. 4 is 1 upon 6. Probability of getting 5 is also 1 upon 6. And probability of getting 6 is also 1 upon 6. So you can see that here all the probabilities are equal. And that is why it is called the equally likely outcomes. Now you can understand what is the meaning of equally likely. That means all the probabilities are also equal. Here also the probability of getting head and tail are also equal. That is why it is called equally likely outcomes. Right? So is there any other events are possible? Yes. See, getting even number, that is also an event. So what is the probability of getting even numbers? Now see, how many outcomes are there? 6. Out of that, how many are the even numbers? 2, 4 and 3. 2, 4 and 6. That is the 3 outcomes which are even numbers. So the getting even number, that means required outcomes. Required outcomes is how many? 3, and the possible outcomes are 6. That we have to put in the denominator. So when we cut 3 and 6, we get 1 upon 2. So here we get the probability of getting even number, that is equals to 1 upon 2. In the same way, think about the event, that is getting odd number. So here also probability of getting odd number is, how many odd numbers are there in the outcomes? 1, 3 and 5. 3 outcomes are there which are odd numbers, and the total outcomes is 6. So here also we get the probability 1 upon 2. So 2 more events are added here. So here we have write down only 6 events, but these 2 events are also added here. In the same way, many more events we can get here. Like number we want, that must be greater than 1. So that is also becomes an event. So now number greater than 1 means 1, 2, 3, 4, 5. So 5 outputs that we require. So the probability of getting number more than 1 is equals to 5 upon 6. So in this way, events can be added here. But this thing is not possible here because there is only 2 outputs, either head or the tail. Understand? So this is all about how we can get the probability, what is the introduction, what is the basics of the probability. Okay? So this is all about this lecture. Thank you.